All right, here are the notes for section 4.5, which is with the graphs of the other four trig functions, the tangent, the cotangent, the secant, and the cosecant. So to start with, we have the tangent function. So here's the graph tangent function, just some definitions. So the domain of this function is all reals, x not equal to k times pi over 2, where k is any odd number. So if you notice, we have these vertical asymptotes at pi over 2. There's an odd 3, -1, -3 pi over 2, so on and so forth. The range for this function is all real numbers. It goes all the way top to bottom. Let's see here. What else do we need to worry about? That's about the important part of it, so there you go. Okay, so describe the graph of the function y equals negative tan 2x in terms of basic trig function. So this is based off of the tangent x. So this negative sign out front will do a y-axis, an x-axis reflection. And the 2 out front will be a compression horizontal, or a shrink, if you want to think about it that way, of 1/2. So, well, that's a bad way to phrase it. Shrink of 1/2, compression of 2, because it's half as big as it was. So the second part here, locate the vertical asymptotes. Well, normally there's vertical asymptotes here, but since we've cut the graph in half, we have to multiply this by 1/2. So there's going to be a vertical asymptote at every odd multiple of pi over 4 instead. All right, so we've got the cotangent function. Looks like this guy. So let's see here, some important things for the cotangent function. Would be, let's see here. What do we got here? So the domain, all reals, except this time you notice we're multiples of pi. X not equal to k times pi, or k is a any number, actually, integer. So 0 doesn't work, 1 doesn't work, 2 doesn't work, 3 doesn't work, 4, so on and forth, -1, -2, blah, blah, blah. Range would be all reals once again. Graph runs top to bottom. All right, so describe the graph of this in terms of a basic trig function. So this is based off the cotangent function. So 3, we're going to have a vertical stretch of 3. We're going to have, so it looks like it should be half, so we're going to have a horizontal stretch of 2, or if you want a horizontal compression of 1/2. Compressions are backwards. It looks like it should be getting smaller because you're dividing by 2, which means you're actually stretching it. So a stretch of 2. This +1 is going to be a vertical, all right, we'll just call it up. Oops, off the screen. Up 2, whoops, not up 2 units, just up 1 unit. Vertical asymptotes. So let's see here. Because of this stretch of 2, instead of every integer, we're going to have to double every value. So the asymptotes are just the even multiples of pi. So we have to double this. And anytime you double any integer, you always get an even value. So the vertical asymptotes occur at k times pi, where k is even. Positive or negative, doesn't actually matter. Alrighty, the next one, this is the graph of the secant function. So the secant is the reciprocal of the sine function. So if I actually sketch the sine function, you'll notice that any place the sine function, sorry, this is the reciprocal of the cosine function. Any place the cosine function crosses through the axis through 0, this has a vertical asymptote because that's how it works. So let's see here. So find the value of x between pi and 3 pi over 2 that solves this equation. Oh, okay, we're gonna do some algebra here. So before we'll do the domain up here. The domain is all reals, x not equal to, so it looks like it's the same as tangents. K times pi over 2, k is odd, so 1 pi, 3 pi, so on and so forth. Range is either y greater than 1 or equal to y less than equal to negative 1. So if you want the interval notation, that would be, let's see here, negative infinity up to negative 1. That's the bottom parts of the curves, joined with from 1 up to infinity. Okay, so we got to solve this equation. So the first thing we're going to do is, I don't like working with secants, so we're going to do the reciprocal step. Secant is the same thing as 1 over the cosine. So I can, reciprocal is an operation as long as you do it to both sides. This becomes cosine x equals negative half. The other way to think about it would be to do cross products. So this would give me negative 2 cosine x equals 1, and then you'd end up back there anyway. So find the value of x between pi and 3 pi over 2, pi and 3 pi over 2 that solves this equation. So I'm looking for, so here's pi, here's 3 pi over 2. Cosines are always x values, so I need what angle does the point end at negative half? Well, negative half is like right here, so I'm talking about this angle here. So you can either look on your unit circle actually for the angle between pi and 3 pi over 2 that has an x value of negative half. But if I remember right, from 1, 2, 3, it is 4 pi over 3. So that's just something that you would have to read off of your graph. Okay, and it looks like the last one, the cosecant function. So this guy's the reciprocal of the sine. So the domain, all reals, x not equal to, looks like we're doing multiples of pi. K times pi. Is this the same graph as I had before? Oh, no, it's not. So any multiple of pi, or sorry, k is a integer. You can't just say k pi because then k could be anything you want. Range is actually the same as it was for the secant function. So from negative infinity to 1, whoops, not that kind. Start over. Negative infinity to negative 1, and then from 1 to infinity, or y less than or equal to negative 1, that's the bottom half, or y greater than or equal to positive 1, that's the top use. Okay, find the smallest positive number x, just the x squared equals cosine x. Okay, so let's try this guy. So I don't actually like cosecant, so we're going to make that the reciprocal of the sine. So that gives me this. The problem is there's no good algebra way to solve that, so we're actually going to come to the graph. Menu, oh, make sure I'm in radian first. Nope. Your graph and trig functions, make sure in radian. Okay, so I'm going to graph x squared, and I'm going to graph 1 over sine of x. Now, also the reason I had to make this 1 over sine x is that your calculator doesn't have a cosecant button, so you need to do the reciprocal functions. I'm going to draw these, whoa, and then I'm going to look for the intersection points, because that's where they're equal, so G-solve intersection. Let's see here. So it wants the smallest positive number. Okay, so well, that's a negative x, negative 3.2, so it can't be that one. So it's got to be this one. So x is about 1.07. That's the smallest value that works. Down here, we've got a summary. So the 6 trig functions, sine, cosine, tangent, cotangent, secant, cosecant. So periods, so how long it takes to repeat a full cycle, the domains. So here they wrote it a little bit differently, and pi and pi. all reals, so this is where n is a number. Your ranges, so we talked about those. Asymptotes, if you have them, if you notice, the asymptotes are where the values are not in the range. Your zeros, which is where it passes the even, and whether the function is even or odd. So that does bring us to the end of the section.